Hi everyone, this is Anita Larson. I'm the Director of Marketing for Care Analytics. Welcome and thank you for joining our webinar today. For those of you not familiar with us, Care Analytics is a cloud and analytics solution partner, and that basically means that we migrate, build, and integrate and manage applications in the cloud. Today we are joined by Scott Opitz, the founder, president, and CEO of TimelinePI, and Alex Diebler, Senior Solutions Consultant. Now, TimelinePI is a new way of automatically analyzing data to understand, optimize, and monitor processes. They have joined us today to tell us more about how their solution can be used for healthcare organizations and to show us a brief demo. But before I pass it over to them, just a couple of operational items. We will be sending out the recording of the webinar to all attendees. So if you want to view it again, don't worry, you will have it. If you have any questions at all for Care Analytics or TimelinePI, please submit them here and we will respond to you within the next business day. And with that, thanks again for joining, and I am passing this over to Scott and Alex.
Thanks, Anita, and good morning, everybody. My name is Scott Opitz. I'm President and CEO of TimelinePI. What I want to talk to you about this morning is a new way of analyzing data using a technique called process intelligence. Now, this is particularly germane in the conversations related to healthcare, because if you think about it, everything we do in healthcare is in fact a process. So whether that's a business or operational process for back office operations, revenue cycle, and the like, or it's a clinical protocol for how we treat patients and how we track the treatment of patients, everything is a multi-step process. For those of us who have gone through courses like operations research or other types of process optimization courses, you may be familiar with the work of William Edwards Deming, who was a pioneer in quality and process improvement initiatives. So if we take a little bit of literary license here and apply some of Deming's methods to healthcare, we can distill it down to three interesting points that I think are very applicable. The first is, we have to understand that quality improvement, and therefore process improvement, is really about the science of process management. I cannot improve the quality of something if I don't understand the steps in how I perform it or execute it. The second point, as we all probably have heard in different forms over the years, is that if you can't measure it, you can't improve it. If I don't understand what my baseline is, how can I know if the changes I'm making or the actions I'm taking are actually going to put me in a better situation? Then the third point is, of course, you can do all of this work, but unless you can get the right data in the right format at exactly the right time in the right hands of someone who can actually take advantage of it, you're really going to be hard-pressed to make very many improvements. So as we think about processes in a hospital, processes are everywhere. Everything we do is a process. Everything's a series of steps. And so therefore, as we think about optimization, we have opportunities to improve those processes everywhere as well. The areas where we can find them could be as diverse as everything from analyzing patient navigation and case management. How well and how fluidly do patients flow from one service area to the next? How well do we execute particular critical actions that we're supposed to take to help better manage somebody's health in our population? To patient safety and risk type issues, where can we detect that in fact one of our staff or one of our coworkers may have a situation where they fail to comply with a required protocol or procedure that may actually put us in an adverse situation as far as risk with respect to a patient. To do research around clinical guideline, to find cases where in the histories we could actually find evidence that we might be able to find a more optimal care path, and so on, to revenue cycle management, what patterns of behavior and even what processing patterns might lead to higher first-time denial rates on the organization getting reimbursed for its services, population health, accountable care organization activities, how well are our populations actually adhering to the behaviors that we modeled, and then ultimately how well are they staying within our ACOs so that we don't have leakage, that we can have a more predictable financial model. And then finally, from a general administration perspective, when I'm tracking cross-departmental service level agreements, that one organization or one department is committed to deliver services within a certain amount of time to another department, how well are we performing on that? Of course, a lot of this is common sense. We all know that these are things that we should be doing. But currently, we have a challenge, which is that the tools that we're provided with to do this work, frankly, fall short. And so, because there aren't really any tools that are geared historically to helping me understand my processes as holistic processes, we generally have to revert to manual approaches, very labor intensive. So, people try to reconstruct processes, piece them together, go around and try to do time and motion studies, interview people to try to figure out how work gets done, and then hopefully try to complement at least that with data that they can find in a system. But the problem is these techniques are very time consuming, and they tend to be very error prone because, in fact, they generally at best can only do a rough sample of what's actually happening in high volume situations. Of course, there have been, over the last decade, there's a tremendous increase in popularity in the business intelligence tools. So I'm sure many of you have had many initiatives around building reports and dashboards and other types of presentation mechanisms where you can actually see your data in a new way or get more ready access to it. But the problem is that these business intelligence tools, while they do serve a purpose and they actually do add value, they really can only work on presenting information related to one set of facts at a time. So I might be able to look and see that here's how many patients arrive at the ED at a certain time and how that spreads out over the day. But I can't see what happens to those patients from a process perspective as they flow through their journey through our organization. And so there are also other technologies that are out there that vaguely relate to processes, but unfortunately they don't really help me in this analysis of what happens within my organization. So that takes us right back to what we learned earlier. You can't improve what you don't understand. If your tools will not help you get these answers, how can you possibly know what to do to fix the problem? Well, that's exactly why TimelinePI exists. We're all about providing you with a completely new approach to analyzing, optimizing, and monitoring your business processes. So, how do we do that? Well, it's all based on a new type of data analysis technique called timeline analysis. And you can kind of think of it broken down into what we like to call 3 pillars. The first is the ability to quickly load up data and then discover your current state. How are things working today? Then to be able to, once you understand that current state, to be able to drill in a little more deeply and ask some much more pointed types of analysis questions. And then finally, once from that analysis you're able to hopefully affect good change, come up with more optimal ways of executing your processes or complying better with the rules that should be in place, we then can actually go into a monitoring phase to make sure that people actually adhere with the new way that they're supposed to be doing things. So let's take a look at each of these a little more closely. In phase 1, discovery phase, it's all about understanding your baseline. This is all about understanding how things work today. We're not changing anything yet. We're just trying to say, how does it happen today? And we do this through a variety of different pre-built techniques. And again, you're going to see these in an example here shortly. It's the ability to go and take data from one or more different systems and immediately reconstruct all of the different process flows, which in many of our cases simply means, for instance, patient flows and everything that happened to them, through what we call our timeline analysis. Then to look across a collection of different patient flows or timelines where there's a huge amount of variability from one case to the next, the ability to look for the possibility of a common schema that might explain, even among all the noise and all the variability, the general flow of patients, or, by the way, maybe multiple different subsets of flows that may apply to different cohorts of patients. And then finally, as we look at different cross-sections of patients, even those patients which may seem to have a great deal in common, we might want to actually look to see what kind of variability we have in the execution paths across those patients. In other words, how often do they go down through a series of steps, through one sequence of steps versus another? Now, as we move on to the second phase, now that we understand our baseline, that we have a sense of where we're starting from, well, now we're going to get a lot more pointed in our questions, right? So now we want to go in and take advantage of that baseline data, but also maybe derive some additional insights and really get a lot of facts on which we can base our optimization planning. So this is where we introduce some advanced features, such as our ability to query for certain types of execution patterns. How often do we have a case where we do this step and then within a certain amount of time we do another step, but we neglect to do some step within a certain amount of time and then we have some sort of outcome? Well, I may want to look at that for any number of different reasons, and so we'll show you an example of that. The ability to look at time intervals, which is always critical, of course, right? As we want to look at the amount of time it takes to get from one step to the next. That has a lot to do often with many different measures of quality. And then finally, workflow analysis, the ability to look across different work teams or different groups and how certain groups may be more adept at handling certain types of situations than others, whereas those other groups might be better at handling a completely different set of circumstances. So we're going to look at those a little more deeply here as we get into the demonstration in a moment. So as we go on to the final phase, where we're looking to make sure that anything that we learned from our earlier steps, where we now have a very good understanding of what happened and we can formulate a strategy on how to do things better, now we want to make sure that those changes that we've made are actually complied with by the organization. So we want to be able to monitor that processes are executed in a way that, in fact, we said were favorable. If we detect anomalies or deviations from those types of definitions, we want to be able to alert somebody immediately so that they actually could possibly go off and verify why it's happening and is there a way to potentially mitigate a negative result of it. And then finally, for those of us who aren't going to be living inside analysis tools, we have people on our staffs who aren't going to want to go in and try to do all that research, but they certainly would like to know how their areas are performing so that they could be both alerted and see statistics about how things are working. We offer operational dashboards for that so that the non-technical person can actually see the benefits of this. What I'm going to do now is I want to turn it over to my colleague, Alex Deibler. Alex is a senior solutions consultant with TimelinePI. And what we've asked Alex to do today is to take you through an example of TimelinePI in action, looking at a emergency room data set. So this is a data set that happens to come out of Epic. So this is going to show you a couple months worth of activity of patients flowing through an emergency department. And he'll take you through a number of the different types of analyses that we can do as an introduction to the tool. So with that, Alex, over to you.
Thanks, Scott, and good morning, everyone. As Scott said, today I'm going to be going through a demonstration of TimelinePI, which is going to touch on all of the aforementioned functionality, including the process discovery mechanisms, the different analysis modules, as well as the monitoring capabilities of the tool. So let's get started with the tool. So we're going to be going through the creation of this project from scratch to show you how easy it is to get started using TimelinePI and how quickly you're able to get insights into your business processes in such a short period of time. So the example we're going to be going through today is based around the flow of patients through an emergency department. So I'm pointing out to a file that's got some events related to this ED process. And the main data source we're actually going to be pulling from here would be something like Epic or Cerner, a widely used medical record system. Now there are only 3 fields which are required in order to get started. Okay, and actually there are these fields that you can see in amber. The first required field is our timestamp. This is simply going to tell us when an event has occurred. The next one is going to be our timeline ID, our unique identifier. This is going to be the ID that allows us to join together all these different events in a given patient instance into the same context. So for this example, we're going to be using an encounter ID. So each time a person presents themselves to the ED, they're issued an encounter ID. They go through the series of steps through the emergency room. If they were to come back tomorrow or the next day, they would be issued a separate encounter ID, and we would track that as a separate process instance. We've also got a field here that's required that is our event name. And this is going to tell us simply what work happened at that step. So triage was completed, the patient was roomed, a provider was assigned. Those are some of the examples that you'll see. So those are the only 3 required fields we'll need. And lastly, you can see we have these fields that are mapped in purple, which you would consider to be dimensions, ways that you want to slice and dice, filter, give more context to this data by. So the day of the week that the patient came in on, how did they come in by their means of arrival, the comments, or this actually contains things like lab tests that were ordered, and the acuity level by a score. Okay, so you can bring in as many or as few of these purple dimensional fields as you'd like. Now it's worth mentioning that these timelines can be assembled from multiple files which are going to correspond to separate systems of record. So different events can come from totally different sources, right? This is a relatively simple example that we're going to go through and manual at that, right? I'm pointing out to a file. We have a much more automated fashion of getting data into the tool. I do this simple example just for the sake of showing you how data mapping is done and the required fields in order to get going. But of course, we can point to multiple systems that underlie a process, and the tool is smart enough to join them all together as long as they contain this timeline ID, that shared timeline ID. You can then load up those events and the tool will insert them into the correct corresponding timelines regardless of that system they've come from. So we've mapped some columns in this file. What I would do is simply hit load and allow the tool to begin reconstituting the process. I'm not going to waste our time today doing that because it would have taken us about 90 seconds to load what we have here, which is 500,000 events related to these patient encounters. As I mentioned, in that time we're going to reconstitute the process, build all the models we're going to go through, and create the multiple forms of analysis. So once we've successfully loaded data, we're presented with the overview page, which includes quite a few metrics that are going to give us a better understanding about our project and, of course, this process that we're looking at. So the first thing I'll point your attention to, almost 450,000 events came out of that file, and it was mapped into 23,472 timelines. In this case, a timeline is going to be synonymous with a patient encounter. So 46 different types of events came out of that file. I'll pop this up just to give you a look. You can see all the different events listed here. I can sort them by the most commonly occurring events, right, or those associated with the most timelines or encounters. Now, just in the interest of full disclosure, I've done one other thing other than load up this data prior to this demonstration, and that's assign a couple of icons to be used as opposed to the default circle with the number in it. So I'll just give you a quick look. You can choose to assign your own icons, use the ones we provide, use coloring. The idea here is just to give users a very obvious look when they first come into the tool, exactly what's going on in this process. And you'll see this will become more apparent when we get into the timelines view. So other than that, everything else automatically done by the solution. So some of the other metrics that we've got here, the average duration on the range of duration. So on average, we process patients within 5 hours, but it can range anywhere from 0 to 35 days, which would seem like an inordinate amount of time to be in the ED, and we'll come back to that. The number of events in our process or encounter instances. We've also got some cost metrics. So we'll touch a bit more on this in detail, but it's cost us essentially $9 million to process this full population of patients that we've got within the tool with an average cost per patient of $384. We've also got the distribution of the first and last events in this ED process. So essentially which events are most commonly both starting and finishing these patient encounters. Now I'll pop up this first event list and you get a full listing of all the different possible events which have kicked off or started the ED process, and I'll just show you this data actually came out of a real engagement that we had with a large healthcare system here in the Northeast, and obviously has been heavily de-identified, but we were all kind of scratching our heads at the ability for ready for discharge to be the first event in a part of an ED process. Doesn't seem to make much sense, but in 2 times it actually occurred. The point really here is that we're not constricting you to an expected workflow or this is what we think is happening. We're simply allowing the data to tell us the story about this process. So from here, let's move on to the actual process path which the tool has generated. So these are our timelines. Now, what we have in the center of the screen, each of these horizontal lines represents a separate patient encounter, and the circles with the icons that I mentioned are the events that occurred with this specific patient, for example. Now, if I scroll to the right, you'll see the length of these timelines is proportionate to elapsed time. So, of course, some are going to be longer than others. We've also got what you can see as time gaps in between events where essentially no work is happening as a part of these events. Now, if I click on any one of these timelines, it's going to give me much more detail as to exactly what has happened with this patient, in what order, and at what time. So I'll come back to these sub-processes. What we're looking at is the detail specific to timeline or patient number X, essentially. Now, this column that we saw all the way to the left is a superset of all the events which occurred with this patient. So we can see when they arrived, when triage starts is completed, when they're roomed, they have labs ordered, so on and so forth, until eventually they're probably exiting the ED, they're discharged. Now you can see we have long time gaps highlighted for us here. We've also got all that attribute information that I mentioned, right? Who is associated with this patient at each given step. Now when I turn back on the sub-processes, what you'll see here is these additional columns to the right. The tool is automatically figured out by analyzing specific patterns in this data, which things were most commonly done together or as mutually exclusive steps. So in other words, it automatically detected those things which are done as sub or parallel processes, and you can see those broken out here. Right? So I'll give you a quick example. You would expect everybody who comes into the ED is going to arrive and get triaged, probably get roomed, but not everybody's going to have lab orders or x-rays ordered. And so you can see those types of events broken out here and grouped together as the sub-processes. Okay? The idea here is just very quickly to give users a very, at least in this view, a very granular look at exactly what's going on with the process, right? So that we can ensure that we're following the expected workflow. So if we think about loading up data across multiple systems, we're essentially piecing together the composite life cycle of this patient throughout their entire ER visit, regardless of the system of record, which would be responsible for recording any of these given events. Okay, it's worth mentioning here. The engine itself, this tool doesn't know the first thing about healthcare or emergency room. We could just easily be doing this with insurance, shipping, revenue cycle management, logistics, invoice, whatever it is. It's totally agnostic to the industry. Again, the idea is to give users a much better understanding very, very quickly of what's happening in the business process, regardless of the vertical that it's supporting. So there's a huge amount of variability in this ED data, right? And in most healthcare processes. After having worked with this specific set, I can tell you there's no two timelines which are actually identical. So when we start off customer engagements, oftentimes we'll be asked, this is great. This is a lot of information, of course. There's 23,472 patients. You really can't wrap your arms around it. So I want to understand just what's our general workflow look like, right? And it's a question that a lot of businesses will struggle to answer currently with their existing technology set. Is a big reason why when we go in and talk with people, a lot of times they can't tell us with a high degree of confidence exactly how these processes are being executed. So let's look at our process schema editor. This actually gives us the capability to map that most common path through the process. Okay. I'll first name my process. We'll start out by allowing the software to take what it believes to be the most important milestone events. So when I click this select default milestones, what's happening is the tool is using advanced statistical analysis, specifically picking the events which are most reliably and commonly occurring at the same point of our process. So it looks like it picked out 8 milestone events for us, which is great, but there's some others maybe I'd like to add to the model here. So let's include where the decision to admit is being made, where patients are being admitted, and also maybe where providers are being assigned. So I've added a couple more. Let's have it generate the default schema. Now this is showing us that most common path that patients are taking based on the events which I've essentially said that I care about. Okay. What's nice here is that this is not a static Visio diagram. Once I choose to save this, it can now become a monitoring tool. So you can see via the thickness of the lines where more patients have gone one transition versus another, and you can mouse over and get the number of transitions which have taken. Right. And if we don't want to look at this by the volume of patients which have gone one path versus another, we can break it down by the amount of time spent in these transitions. So when I change this metric to the time length, the thickness of the line is representing where are we spending the bulk of our time in this ED process, and I can mouse over again and get the average duration between any two transitions. Now this is going to show us, of course, where the majority of time is being spent. If we're looking for ways to improve efficiency, this is probably the portion of the process we're going to want to start to look at. This could be ripe for automation or re-engineering, what have you. Now, we can even take this visualization a step further and start to animate and watch where patients are backing up as a part of our workflow. So when I turn on this animation, you're going to see each one of these circles represents a patient or a group of patients. We can see as they go through this ED workflow where things are starting to slow down, maybe start to bottleneck and back up. As things are changing color, that means that they're aging within the process. They've been in the process longer. Now, if anything stands out here, I've just paused the animation. If anything stands out here as, a bit of an outlier, for instance, this one that's been in the process quite a while but still back up by triage, we can actually click on that and drill directly into this specific patient encounter and get a very detailed look at exactly what happened with this patient, who was associated with it, right? What was going on, so that we can take action if we need to. Okay. But to turn back on the animation, we can clearly see where things are slowing down, if things are backing up and bottlenecking, or just spending too much time within the process by using this animation tool. Okay. Now that we have a much better idea of generally how patients are going through our workflow, let's go and take a look at some of the more one of the forms of analysis that allows us to take a look at the amount of variability. There's a huge amount of variability within this data. So now that we have a general idea, let's look at that, and that'll be our path analysis. Okay. Now what this is showing us is a frequency distribution of all the different possible process paths, the ways that this process was executed, with the most commonly followed behaviors here to the left. So we've got our events or steps here listed along the left. You can see the count of timelines or the number of patients and encounters which have gone one path versus another. This is going to clearly expose where we've skipped steps, gone back to complete steps, done things out of order, have pinballed maybe, or repetitively done things, right? With our most commonly followed behaviors highlighted here for us. Okay, so as you scroll to the right, there's any number of different ways that this process has actually been executed. Now you can see we've got some other metrics here along the top, so I can actually look at this from a timing perspective to see on average how long does it take us to go one path versus another. Right? And if I see something that stands out as just not being efficient, or of course I can see things that are not compliant when we've skipped steps or gone back and repeatedly done things. But if I want to look at this from a timing perspective, I can start to hone in on exactly what activities or patterns of behavior are causing us to take longer to process patients, right? Or I can change this metric and get a better feel for exactly how much is it costing us to process these patients when we go one path versus another. So this is showing us the average cost of this execution path versus all of the others. So now we can start to make these process reengineering decisions with the bottom line in mind, right? Because I can start to push people towards a more efficient costing way of processing a patient from versus just saying we need to go do it in this specific order. Now I can see exactly how much it's costing us, right? And allow us to get to that level. Now if I see a specific path or set of steps that looks like extremely problematic or could be a risk to the business, what I can do is actually start to hone in on that. So let's just use this path with 58 patients which have gone this specific route where you've skipped a couple of steps and come back and so on. What I can actually do is click on that specific path or behavior, apply it as a filter. Now when I come into my timelines view, I'm only looking at those 58 patient encounters that exhibited that specific behavior which I deemed non-compliant, and I can drill much quicker down and start to look at things like root cause, which we'll be getting into here shortly. Right? But this filtering mechanism will be a theme you'll see as we go. We'll start with our large data set. We'll start to use some of those analysis applications or modules to manage it down, to whittle it down to more manageable sizes, right? So we can start to uncover these interesting things that are happening in our workflows. So let's go back to our full data set. Now let's transition. That was the discovery pillar, right? We really didn't have to do much from a configuration perspective to get that level of insight we just got, right? Now we're going to move on. Once we have that general as-is state, we understand what's currently happening within our ED, we want to start to ask some questions of the data. So let's look at some of the mechanisms we have for asking those questions and kind of putting our analyst hat on. So we're back to our full patient encounter data set with 23,472 records. And this is just far too many to scroll through and really be able to start to digest. So we can start to use the metrics along the top to start to get a better understanding of this data from a high level. Now these metrics are always going to be representative of the set of timelines that we have in the window below. And so you're going to see these recalculate and change dynamically as we filter and scope our analysis, just like we just did with the path analysis. So right now we're looking across all 23,000 plus patient encounters. And this duration metric, as I mentioned in the beginning, stands out. The fact that there's at least one case which took 35 days to complete is pretty odd. So let's drill a bit deeper into this. When I click on our duration metric, I'm presented with a histogram which shows me the distribution of all of my cases by their duration. So I've got the average along with the maximum throughput time for patients. And thankfully, this large spike here towards the left says the majority of our patients are done in far less than 35 days. But adjusting this slider dynamically calculates how many cases fall above or below the threshold that I've set. So I've set it at 1 day, and it looks like we've captured almost 98% of our cases, but there's still 520 outliers, or 2.2%, which are outside this window. So if I'm looking at this from an analyst perspective, let's drill a bit further in on these. Now I can apply this as a filter. Now we're only looking at those 520 cases which have a duration of longer than 1 day. Okay. Now, in working with this hospital initially, they were concerned that it was the lab test. There was a lot of scuttlebutt, but people were concerned that it might be the lab that was holding up these patients. It was just taking too long for these tests to be returned once the patients were roomed in the ED. Let's try to hone in on exactly how long these labs are taking by using our time interval management tool. Okay, so this actually has my settings from an earlier job, but what we're looking at is the delta of time in between a lab ordered event followed by a lab result. So how long is it taking us to process these orders? So as always, we show you the minimum, the maximum, and the average amount of time, as well as the distribution. So while the average time in these cases is almost 88 minutes, it looks like there's a skew here. So you can drag this out and start to get a feel for things that are taking longer than 1 hour. And the fact that there's at least a few cases that could take over 2 days to return a lab test, that tells us that they could have been right about that. It's quite possible that the labs could be holding people up if it's taking them just far too long to return the results. Now, what we want to do is start to break into this and see if there's any kind of trends in the data that are going to lead us to a root cause analysis. Right? Is there anything that stands out that tells us, is it a particular type of test? Is there a certain provider that's working on these long-running patients, essentially? And we can first do that to look at this by the breakdown analysis. So let's bring that up. And it looks like what we've selected here is the lab ordered event, and now we're breaking it down by the comments, which actually contains, as I mentioned, those lab tests. And interestingly enough, it looks like there are 2 labs specifically which stand out. So it's quite possible that we want to take these up with the lab techs and say, what exactly is it about these lab tests that's just taking us longer than most to complete, right? We need to work on driving that turnaround time down. We can also choose to break this down by any of the different dimensions that we've got within our data set, right? So let's look at this not by the different labs, but the different doctors or physicians that were associated with these patients. Are there any trends that we can kind of pick out here? And it looks like a relatively even distribution, but you can imagine if there was 1 or 2 doctors that were just consistently associated with these long-running patient encounters, you would know exactly who to go speak to, right? From a procedural perspective, or just getting a better feel for exactly what's taking them so long that they're associated with such a large amount of our long-running cases. Okay. Now, from here, let's double back and we'll take a look at one of the query or search mechanisms. But before we get to that, you see I've set a filter. I just want to give you the concept of how we would create a set of data within the tool. So if I pop this up, you get a look at, I have a filter set on the duration of timelines. You can imagine I could set multiple filters on our data that are going to intersect and whatever type of analysis I'm looking to do. And once I've done that, I may want to save that filter configuration and come back to it at a later time. So what I can do is choose to save this as a set, and allows me to come back to this in just one click. I don't have to reset all my filters again. But it also gives me the ability to now go off and do cohort analysis. Because if I can create one set of data, whether it's one doctor's patient or just my long cases or maybe just data from last week, I can now compare that and do a side-by-side analysis versus any other set of data. I can do it against my full patient population. I can do two physicians, one against another, and so on and so forth. So it allows us to do that cohort analysis and get a feel for how things are trending from a side-by-side perspective. So that's saving a set. I'll clear out this filter for now and we'll move on to what I think is one of the very, very powerful aspects of this tool, the search or the query mechanism. Now, if you think about a traditional BI-based search, you're going to look for objects by using their current attributes, those dimensions we talked about earlier. But what if we need to look for things from more of a historical perspective, a pattern-based perspective? So I'll just pose a scenario for you, and let's see if we can think about a way we would answer it in a BI tool. If somebody were to ask this question, how often do we have a scenario where we've got lab results being returned before there's any record of a lab test ever having been ordered, right? It seems like something that we probably shouldn't be occurring, but by using a BI search, you'd have a pretty difficult time answering that type of a question. You probably would require some custom code. So I'll show you how we can graphically build that out here in the tool. Actually, first, what we'll quickly take a look at, I think is actually an interesting feature, is the ability to hone in on these lab ordered events. So I can click on my lab order. I get a distribution of how many times this specific event has occurred. So it looks like our labs there could be 20 different lab orders in a part of these patient encounters. But I can actually align by this event. So as to look at like this lab has happened at the same time for every patient encounter, I can get a very keen look at exactly what's happening both before and after my lab ordered event. Right? And as opposed to scrolling through and looking for that condition that I just mentioned, we can start to use the query mechanism to search by that. Okay? So let's build out that graphical query. We'll say we've got a lab ordered event followed by a lab result, right? But in this scenario, we're saying we haven't had a lab order placed, yet we've received results. So this is just a way to quickly go off and test a hypothesis. Is this happening within our data? I go off and click search and get a very quick response. Actually, in 391 patient encounters, we had record of a result prior to an order being placed. That's interesting. The beauty of these queries is they don't have to necessarily be that simple. So I'll bring that back up. Let's add a bit more to it. Let's say we're only interested when the patient arrived in the ED, but only on Sundays. So let's limit it to Sundays. Okay, maybe one lab result without an order. It could be a quick glucose test or something of that nature on triage. That's not a concern. Let's say only 2 or more lab results without an order being placed. And also, I want to look at only patients who were admitted into the hospital, but those who had a time gap between that last lab result and being admitted of greater than 30 minutes. So you can see we can build in time here extremely granularly into these queries, into these searches to start to look for inefficiencies, monitoring SLAs, right? We can get very detailed as to the questions we're asking. So anyway, I've made this quite a bit more complex. Really, I don't know how you would answer this in any other tool without a custom application, essentially. Anyhow, let's go off and search it. I should get a pretty quick response time. And you'll see actually in 39 patient encounters, we had that specific scenario occur. Okay. And another aspect of these queries, and what I think is a really powerful aspect, is that we don't necessarily need to be in here running these every single day and babysitting this data. We can set these up to drive proactive alerting. So that's the monitoring aspect, right, which kind of overarches all this. Once we build in this condition and we see it's happening within our data, I want to build an alert that says, I don't ever really want to get past this certain step and move on to anything downstream without somebody being notified that this is actually happening. Building that level of accountability into our process, and these alerts can be sent by email, SMS, they can connect via web service. So that's a really powerful aspect. I don't want to be running this manually. I want to set it, I want to understand it, and now I want it to notify me when these types of things are occurring. Okay. So let's look at one of the other analysis applications, and that being our protocols. Okay, so as we get into more specialized forms of asking questions of this data, protocols kind of fit that mold. And a good example, not as much healthcare related, but one I point to is in financial services. When somebody applies for a consumer loan or a mortgage, you absolutely must get certain disclosures, estimates, signatures, these things that the government are required for every single loan, right? And these things are mandated, and if they're not done in the prescribed way, and in certain cases in a certain time frame, you're going to be in violation of federal law, and your loan application will essentially be null and void. So most processes, and especially in healthcare, include areas where when we get to a certain point, there are things that absolutely must happen, and oftentimes within a given time frame. So that's where protocols fit. And in comparison to the query we just looked at, a query is a search mechanism, right? It says, give me all the cases that match the condition that I've just created. A protocol will allow us to define a set of rules which we expect should always be followed. And it's going to show us the timelines which violate that rule, because I'm not concerned, to be honest with you, if things are following protocol. That's what I expect. I want to know when things are deviating. So in other words, it's going to be the inverse of that query. It's going to show us the things that don't match the condition that I've set forth. So this is a simple admittance protocol that I've created. That's essentially saying when a patient's in the ED, we know we're going to do a lot of different things depending on their age, their seriousness, whatever their ailment was. The protocol says that when we make a decision to admit, it should take no longer than 1 hour for that patient to depart from the ED. Right? Now, these are the critical conditions we expect has been built into our process. I want to make sure this is being followed. Now, just like with a query, this protocol can be saved to run as an alert and let me know anytime it's violated. And I probably would set up an alert to notify me at 40 minutes and also at 50 minutes to make sure we don't hit that unacceptable threshold. But as opposed to only looking at new data coming into the system, right? So we got a feed and we scan it and we alert if the protocol is violated. We can also use this for analysis based on the historical data that we've got in the tool. So when I click Show Violations, this shows me not just that my protocol was violated, but it also gives me the root cause. So there's a number of different ways that this could actually be violated. Now you can see something's happened in the wrong position, the wrong amount of times, we had a time violation, something was missing altogether, okay? And now one big consideration here is to not flood somebody with false positives. These are critical notifications. We want to make sure these aren't false positives. And so what we can do is we can build some conditions in here. If I say, patient transfer, that can kind of float. It doesn't need to happen in specifically that specific step. Same thing with patient departed from the ED. That can float in between here. Things can repeat, be concurrent, or be totally optional altogether. Right? So now we've modified it a bit, make it a bit more lenient. Now when I click Show Violations, it's got a fewer number of violations for me to hone in on. Now these are the ones that I'm really concerned with, the ones I might want to drill a bit further in. Now if I see something that I'm interested in investigating further, I can click Apply Filter on any one of these violations and drill directly into the timelines of the patient encounters that made up that protocol violation, just as you see me do thus far. Okay. Now, I'm not going to do that right now, but you can imagine how I would be able to do that. One last piece of analysis that I just want to touch on quickly is the dashboarding feature. Okay, so this is an interactive feature that's essentially built for a business user. Right? As a business manager, you may not want to be logging in this tool to do deep dive analysis. That's what your analyst should be doing. But there may be certain company goals or high level initiatives which you need to monitor, keep your finger on the pulse of the process that you're kind of owning. So we have a basic dashboard capability for those users, and it's obviously a little bit less daunting, more familiar than that timeline view. So the charts on this dashboard are totally interactive and drillable to the extent that I can drill into the timelines that make up that specific piece of the pie that I've clicked on if I'm interested. I'll show you everything is graphically set up. So we can choose the layout, define a couple of metrics, and this can be customized for each end user so that it relates specifically to their business function or what they're concerned with. Okay? But the one thing I want to stress here is that this is not a business intelligence dashboard, right? It's purely a way of surfacing up information that's directly related to the kind of analysis that TimelinePI can do, and that process related analysis that you've seen us go through.
Thank you, Alex. Thank you, Scott. Thanks to Care Analytics for having us today. This concludes today's presentation, Process Intelligence, a new approach to achieving processing optimization in healthcare.